Assalamu alaikum. Another question related to Kirchhoff's law, and this time you have three batteries with three identical resistors connected as shown in the diagram in a triangular way, and you can consider them like connected in series. It's a closed loop, by the way. The batteries have negligible internal resistance, but a resistor R is connected like this. What is the PD between the point P and Q? PD between the point P and Q. Okay. Now since resistors are identical, so why not if I just mark this one and this one again as R? No harm in it. Okay. And since I have to make an equation for this because it's a Kirchhoff's law, so I will assume, let's say, a current I from the 9.6 volt battery is coming and it going towards the next battery and then towards the next battery, the same current. So it means the current I will pass through this R, the current I will pass through this R. Now I am applying Kirchhoff's second law again, because with current and resistance and the values of EMFs, we can only work for the Kirchhoff's second law. So according to Kirchhoff's second law, sum of EMFs must equal to the sum of product of IRs. Okay, so now if I consider the battery starting from, again, now it is my end, but since I have to find out the potential difference between P and Q, so if I just separately draw it like this way, I'm just drawing the end P and Q. This is 9.6 volt and this is R, right? And this is the current I. So afterwards, yahan what is available over here, that would be considered the PD between P and Q. So I even don't actually going to solve anything about this battery and this battery. I don't need to, by the way. I have to go for a shortcut method. So now I'm quickly applying Kirchhoff's second law, starting from this end, 9.6 volt battery. Okay, sorry, that's all right. 9.6 volt, that's my first battery. 9.6 volt. Look at the polarity. Look at the polarity, it's positive. Now I'm traveling towards the next battery, again positive is being offer, so this will be considered minus 8.4, and then the next third battery has a negative terminal, which is minus 6.3, must equal to the product of IRs. Now there is current I and a resistor R, so this is going to be IR, again one another IR, and again another IR. It is going to be 3 IR. 9.6 minus 8.4 minus 6.3. 9.6, sorry, this is going to be positive. 9.6 minus 8.4 plus 6.3, it is 7.5 divided by 3 equals to IR divided by 3, it is 2.5 equals to IR. Now IR alone, guys, IR alone is called a voltage value, which is 2.5. okay, so now, but you can see this is not the answer. Reason because this IR is actually dropped across this resistor 2.5 volts. So if I minus 9.6 from 2.5, the remaining voltage is 7.1 volt, which will be offered between P and Q. And this 7.1 will be distributed here and here. So across P and Q, the answer would be 7.1 volt. Thank you.